Welcome to Functions versus Relations Recap. In this video, we're going to discuss how to tell if a relation is really a function, and we're going to do this graphically with a set of ordered pairs and also given equations. So first of all, it's important to know what a function is. A function is a rule that converts inputs, typically x values, into outputs, which are typically y values. So you put in an x value and you get out one distinct y value. What's really important is that the x values don't repeat with different y values. So in other words, if you put in 3 here, we get out 9. That's a function. What's not a function is if you put in 3 and you get out a 9 or a 5. You know what I mean? You can't have two outputs to one input. Otherwise, it's like, which one do you choose? Now, in order to see graphically if a relation is a function, you're going to do the vertical line test. Now, if a vertical line hits the curve of the graph more than once at anywhere, then it is not a function. So all we're going to do is you're literally going to take a vertical line. You could take a sheet of paper or your finger or whatever. I'm going to make it a different color. Let's make it red. And I'm going to drag the vertical line at every point of the graph. So here at this point, you only touch the vertical line once. Still only touching the vertical line once, but then if you go to the last spot, you're touching the vertical line in 2 spaces. That means for the x value of 3, do you choose the y value of 3 or the y value of -1? That's not good. So this is not a function. We're going to say that this is a relation. A relation is just a relationship between a set of x values and a set of y values. It becomes a function if there's distinctly one y value per each x value. If you do the vertical line test here, you'll notice that each and every point, there's only one point that touches the vertical line. So we're going to say that this passed the vertical line test and is a function. You can probably get the hang of it by just looking at these graphs and you don't need an actual vertical line. Notice here that you only touch it in one spot, but because literally anywhere else on this graph, you touch it in 2 places, this is just a relation and is not a function. By the way, it's kind of like the whole a square is a rectangle, but a rectangle is not a square thing. A function is a relation, but a relation is not necessarily a function because a function has extra conditions. If you keep going with this vertical line test, you'll see that here, no matter where you are in the graph, you're only touching the vertical line 1 time. So this is a function. And you'll see for the next one as well that this is also a function because anytime you drag the line over the graph, you're only touching the line at 1 point per instance. Now, the last one is a vertical line itself. Now, it should make sense that a vertical line will not pass the vertical line test because it hits the vertical line at every single point. So we say that vertical lines are not functions, they are just relations. So keep in mind when you see y equals 4, for example, that's a function. That's going to be a horizontal line. But if you were to have x equals 4, that is not a function because that's going to be a vertical line. Let's talk about how to tell if it's a function with ordered pairs. For each x value, you need one y value. And if you notice here, we have 12, 15, 19, 25, 78. None of those x values repeat, so we're going to say that this is a function. However, in the next one, you're going to see, let's see, we have -1 and -1. And if you look at the corresponding y values, we have 2 and -4. So on the function, if you're inputting -1, do you get out 2 or do you get out -4? It doesn't make sense. So we're going to say that it's not a function. Keep in mind that this one does have y values repeating, but repeating y values don't matter. We only care about the repeating x values. Now I have seen some questions that try to trick kids, and let's say we have, let's go with h. 1, 3, 4, 8, and 1, 3. They'll give you this. So here you'll notice that the x values repeat, but it has the same repeating y values as well. So it's not technically right to write something like this. If you're rewriting the point, it's just redundant. However, it is still a function because we're talking about the same point. They just mentioned it twice. Now, we also have to go over how can you tell if it's a function or not just given an equation without using your calculator to see what does the graph look like. So, for example, if you were given y equals 3x squared plus 2x minus 5. You might not know exactly what it looks like on the graph, but because it's an x squared, I know that's going to be a parabola, and because it has a positive leading coefficient, it's going to be facing up. So the parent function is y equals x squared. Now, there are a bunch of transformations done to this, but it doesn't matter because whether you stretch the function or you shift the function, it's still going to be an upwards opening parabola. So I know that the graph is going to look like this. And that graph passes the vertical line test, whether the parabola is larger or smaller or wherever it happens to be on the graph. So we're going to say that it's a function. For the equation y equals 1 over x minus 5, I know that that parent function is going to be y equals 1 over x. And I know that that looks like this. Now, this graph, you might notice that if you're subtracting 5 from the x's, you're heading to the right by 5. But that doesn't change anything. We still know that in the end, this passes the vertical line test, and it's going to be a function. I would like to point out that my graph is not the best, and it might not pass the vertical line test. But if you were to have a legitimate graph of y equals 1 over x, it would pass the vertical line test, and it is a function. Now, let's talk about this last one. Y equals the square root of x plus 2. You know that the parent function for that is the square root of x. And we know that the square root of x looks like this as a function. So because the parent function is, well, a function, we know that if you shift this graph over to the left, it's still going to be a function. But I want to talk about what happens if we add a plus or minus to the front of it. If you add a plus or minus to the front of it, that's now different because when you're talking about this, your function would normally look like this. I shifted it over to the left 2 because of the x plus 2. Or otherwise, the square root of x just starts at the origin. That's the positive values. But if you're talking about the negative values, you also have to include these. Because think about it, if you have negative square root of x plus 2, the negative on the outside is a reflection over the x-axis, which means everything up top is now going to go to the bottom in the green. Now that you have this, if you were to do the vertical line test, that doesn't pass. So you're going to say that this is not a function if you have the plus or minus in front. Keep in mind that you can't actually graph this as one equation in your calculator. You would have to graph the positive square root of x plus 2 and then graph the negative square root of x plus 2 as 2 separate lines, and then you can see that it's not really a function. But again, we're trying to do this in our mind. And if you're struggling with parent functions, I really suggest that you go back and study the graphs of them. So keep in mind, a relation is a function if each input has one distinct output. That basically means you can't have one x value match with 2 different y values. And also, if you want to test for graph, you're going to use the vertical line test to see if it is a function. If you're given an equation and if you want to know if it's a function, think about the parent function that the equation is related to, if you can compare it to a parent function, and then see if it works out from there. And that's all for this video.